1513, an Ottoman cartographer drew a continent that would not be discovered for another 307 years, not the vague, speculative outline that other cartographers of the era imagined. The rocky terrain lying beneath kilometers of polar ice, terrain that no human instrument would be capable of detecting until 1949, when modern scientists used seismic waves for the first time to see what was hidden beneath the ice cap, and when they compared the results of those seismic surveys with the 1513 map, they found a match. A specific match, documented, confirmed in writing by an officer of the United States Air Force. This is not speculation. This is not conspiracy theory. This is what the data says. We work exclusively with verifiable sources here. Dated documents, signed military letters, published scientific research, and the map itself, which you can visit today in a museum in Istanbul. What we are going to do is examine the evidence that academia prefers to classify as curiosity rather than answer directly. Because when you look at the data without the lens of what should be possible, the questions that emerge are far larger than anyone would care to admit. In 1929, a German theologian named Gustav Deissmann was doing work that few Western scholars had done before, systematically cataloging the archives of the Topkapi Palace in Istanbul. The palace was the administrative heart of the Ottoman Empire for nearly 5 centuries, a labyrinthine structure of chambers, gardens, vaults, and storerooms that had accumulated documents, maps, manuscripts, weapons, and relics from an empire that at its peak stretched from Hungary to Persia, from North Africa to the eastern coast of the Red Sea. There was no complete inventory accessible to outside researchers. There were things there that the modern world simply did not know existed. At some point during that methodical work, Deissmann unrolled a scroll. It was made of gazelle skin, the standard material for high-importance Ottoman documents, resilient, durable, capable of surviving centuries under reasonable storage conditions. The scroll was just over 90 centimeters wide and 60 centimeters tall when unfolded. The ink was remarkably well preserved for an object over 400 years old. The lines were precise. The Arabic inscriptions scattered across the parchment were legible. In the corner, a date and a signature. 9/19 AH, corresponding to 1513 in the Gregorian calendar, and a name, Piri Reis. Deissmann noted the map, recorded its existence in the catalog, and then the work continued, and the map returned to the collection, and the world moved on. For 16 years, no one paid particular attention to what was on that parchment. 16th century Ottoman maps were not exactly common, but neither were they non-existent. And the palace catalog had hundreds of other items competing for the attention of researchers with limited time and resources. The Piri Reis map stayed where it was, housed in an institution that was at once one of the great libraries of the Islamic world and one of the least accessible archives to Western academia. In 1945, the map's existence began to attract more serious scrutiny. Researchers who started studying the document carefully began to notice details that made no sense. Not minor details, not errors or inaccuracies that could be explained by the limitations of cartography at the time. The problem was specific, and it was in the lower corner of the parchment. But before getting to the central problem, there is something you need to understand about the Piri Reis map, something that Piri Reis himself left us in writing, on the document, in his own hand. Piri Reis was not claiming to have discovered what was on the map. He made this explicit in an introductory note accompanying the work, a kind of cartographic preface in which he describes how the map was created. According to his own account, the 1513 map was compiled from more than 20 distinct sources. 8 of them were Ptolemaic maps, reproductions and translations of the work of the Greek geographer Claudius Ptolemy, produced in Alexandria in the 2nd century Anno Domini. The remainder were a mixture of Arabic Islamic charts, Portuguese Portolan charts that Piri Reis had captured during naval battles, and a group of documents he described as ancient maps, sources of unknown origin containing geographical information he could not independently verify. Piri Reis was a compiler, not an explorer. He was gathering and synthesizing geographical knowledge that already existed in some form. And what he compiled, when finally examined carefully in the 20th century, contained something the world should not have known. The question is not how Piri Reis knew. He told us. He did not know. He copied. The question is, who copied before him? Let us walk through the map carefully, because understanding what is right makes what is wrong impossible to ignore. The upper portion of the map shows Western Europe, the Iberian Peninsula, the Atlantic coast of France, the outline of the British Isles to the north. For a map from 1513, it is a competent representation, not perfect by modern standards, but within what you would expect from an experienced cartographer with access to Mediterranean portolan charts and Iberian navigational charts. Portolans were the product of decades of accumulated coastal observation. The Mediterranean was the most thoroughly mapped sea in the world. Europe looks reasonably accurate on the map, and that is no surprise. The western coast of Africa is rendered with a level of detail that reflects the Portuguese expeditions of the 14th and 15th centuries. Bartolomeu Dias had rounded the Cape of Good Hope in 1488. Vasco da Gama had reached India in 1498. Africa was, in 1513, a territory that European navigators were coming to know with increasing accuracy, especially the Portuguese, who had spent decades mapping the continent's Atlantic coast meter by meter. The Piri Reis map captures that knowledge reasonably well, still expected. Then comes the Atlantic. The Atlantic islands are marked with remarkable precision. The Canaries, the Azores, the Cape Verde Islands, positioned with an accuracy that surpasses what most contemporary European maps could achieve. This is not surprising for an Ottoman admiral with access to navigation data from the entire Mediterranean basin and from the Portuguese expeditions, which dominated the central Atlantic at the time. The Atlantic was territory that Europeans had been charting with growing precision since the 14th century. But then comes the New World. And here, the map begins to show something that doesn't fit neatly into the explanation of competent cartographer of 1513. Columbus had reached the Americas in 1492, just 21 years before the date on the map. Cabral had reached Brazil in 1500, just 13 years before. European knowledge of the American continent in 1513 was fragmented, partial, riddled with gaps and contradictions. The first maps of the Americas showed distorted coastlines, incorrect proportions, and an interior that was almost entirely speculative. No known European had comprehensively mapped the American continent in those early years. Despite these limitations, the Piri Reis map displays the eastern coast of South America with an accuracy that would have been unthinkable in 1513. The general curvature of the Brazilian coastline is correct. The mouth of the Amazon River is marked. The indentation corresponding to what we now call the Rio de la Plata is present in roughly the correct proportions. The southern tip of the continent, the region explorers would come to call Patagonia, is sketched in a way that European maps of the same era simply could not reproduce with that degree of fidelity. Researchers who analyzed the map in the 20th century noted that the geographic accuracy of the American section exceeds what Piri Reis's documented sources should have been capable of producing. The Portuguese portolans captured in battle covered known coastlines, but not the full extent of the continent. Columbus's and Cabral's maps were recent and fragmentary, and yet the American representation is, in several respects, more accurate than any surviving contemporary European map. This is where it starts to get truly strange. A cartographer with exceptional sources could explain Europe, Africa, the Atlantic, perhaps even South America. Access to rare portolans, to maps captured from Portuguese navigators, to the Islamic geographic tradition that preserved Ptolemy's knowledge. All of this could, with some imaginative effort, account for an above-average American representation. But South America is not the central problem. It is merely the setup. You're looking at the map. Europe in the upper right corner. Africa running down the side. South America in the center. The Atlantic filling the space between them. So far, remarkably good for 1513, perhaps surprisingly good, but still within the territory of what an extraordinarily skilled cartographer with access to unusual sources could have produced. Then your eyes reach the bottom of the map. There is a landmass there, a long, jagged coastline with bays that recede inland, promontories pushing southward, topographic variations suggesting a mountainous interior. The land begins at the lower edge of the American continent and stretches horizontally eastward across the bottom edge of the parchment. In some places, it appears connected to the tip of South America. In others, the separation is clear. In the 16th century, there was a tradition among European cartographers of drawing a speculative landmass to the south of the known world. They called it Terra Australis Incognita, the unknown southern land. The geographic theory of the time suggested that a great continent must exist in the southern hemisphere to balance the land masses of the northern hemisphere. It was a philosophical speculation more than an empirical observation. Renaissance maps sometimes included this phantom continent along their lower margins, a geographic placeholder for what theory said should be there. This is the official explanation for what appears in the lower corner of the Peary Race map, a speculative Terra Australis, perhaps blended with an exaggerated extension of Patagonia. It is a reasonable explanation. Other maps of the same period do exactly that, until you overlay the lower corner of the Peary Race map against geographic reality. And when you do, what you see is not cartographic speculation. It is a continent that no one should have known existed. The continent of Antarctica was officially discovered in 1820. Russian Admiral Fabian von Bellingshausen was the first documented explorer to sight the continent's coastline during a circumnavigation expedition. That was 307 years after Peary Rice dated his map in 1513. 307 years. No known European navigator had come anywhere near the continent. Ships that attempted to explore the far south encountered ice, fog, impossible temperatures, and death. No cartography of Antarctica existed before 1820. There was no way it could. There was no one who had gone there and come back to tell the tale. Still, inexplicably, the lower margin of the Peary Race map corresponds to the coastline of Antarctica. Not in a vague way. Not with the hazy imprecision you would expect from a speculative representation. The correspondence is specific enough that 20th century researchers, armed with modern maps and geophysical data, were able to identify concrete, nameable geographic features. But that is only the beginning of the problem. Because when you examine carefully which part of Antarctica the map shows, you discover that the matter runs far deeper than a 1513 map depicts Antarctica before its official discovery. Antarctica today is covered by an ice sheet that is, at some points, more than 4 kilometers thick. The coast that the first explorers saw in 1820, and that subsequent explorers continued to chart throughout the 19th century, was the surface of the ice. The outer edge of the ice cap, not the rocky terrain beneath it. The actual topography of the continent, what lies under all that glacial mass, remained completely inaccessible for more than a century after the official discovery. No one knew the shape of that terrain. No one could have known. In 1949, a joint British-Swedish-Norwegian expedition conducted the first seismic surveys of Antarctica. For the first time in history, it became possible to use seismic waves to penetrate the ice and map what lay beneath. The mountains, the valleys, the coastlines, and the plains of the rocky terrain that the polar ice sheet had concealed for millennia. Weeks of labor under extreme conditions, careful measurements, data analysis. The result was, among other things, a detailed mapping of the subglacial terrain of the region known as Princess Martha Coast. When scientists compared the 1949 seismic surveys with the lower corner of the 1513 Peary Race map, they noticed an anomaly that could not be satisfactorily explained by the history textbooks. The Peary Race map showed the subglacial coastline of Antarctica, not the ice surface, the rocky terrain beneath it, the terrain that no human being in recorded history had ever seen, that no pre-modern instrument could detect, that remained completely invisible until 20th century seismic equipment revealed what was hidden there. The correspondence was documented by people who had no reason whatsoever to confirm something inconvenient. In 1960, Lieutenant Colonel Harold Z. Ohlmeyer of the United States Air Force Technical Reconnaissance Squadron, the department responsible for cartographic analysis and aerial reconnaissance during the Cold War, signed a formal letter. The recipient was Charles Hapgood, the researcher who had brought the matter to the attention of military authorities. In the letter, Ohlmeyer wrote the following: "The geographical details shown in the lower part of the map agree very remarkably with the results of the seismic profile made across Antarctica in 1949. Stop here for a moment. That sentence was not written in a conspiracy theory article. It was not the speculation of a weekend enthusiast. It was an official communication, signed with rank and unit designation, from a United States Air Force officer, confirming that a 1513 map depicted geographic data that would only be confirmed by modern science 436 years later. The letter exists. It is filed in accessible records. You can locate it and read it, and what it says has no satisfactory explanation within the historical framework that universities teach. Consider what is technically required to produce that data. To map the subglacial terrain of Antarctica, to know the shape of the rocky coastline that lies beneath kilometers of ice, you need one of two things: modern seismic equipment capable of penetrating the ice and measuring what lies below, or you need to have been there physically when the ice had not yet covered that terrain. There is no third option. You cannot guess the shape of a coastline buried beneath a massive ice sheet. You cannot extrapolate subglacial topography from observation of the ice surface. The information is simply not available by any method the 16th century possessed, or that any century possessed before 1949. The map shows the terrain. The USAF confirmed the terrain is accurate. The only technically possible conclusion is that the sources used by Piri Reis were produced when Antarctica was accessible, when that coastline still lay open to the air, before being buried beneath the ice that concealed it for millennia. When was Antarctica ice-free in this way? Geological data points to the period between approximately 12,000 and 6,000 years ago, the interval associated with the end of the last ice age and the climatic event known as the Younger Dryas. This raises a question we will leave suspended for now, because before we get to it, we need to understand who Piri Reis was, what he told us about the sources he used, and this is where it gets even stranger, what happened to those sources afterward. Haji Ahmed Muhyiddin. Piri was born around 1470 in the city of Gallipoli, the strategic point that controlled access between the Mediterranean and the Black Sea, and that was the operational heart of the Ottoman Navy. His uncle was Kemal Reis, one of the most respected and feared admirals of the Mediterranean, a formidable corsair who eventually entered the service of the Ottoman Sultan and became one of the architects of the naval force that would consolidate the Ottoman Empire's maritime supremacy. Piri grew up at sea, at his uncle's side, learning navigation and naval combat from childhood. He was not an amateur cartographer with grand ambitions. He was a highly qualified professional with decades of hands-on experience in real navigation, naval combat, and coastal reconnaissance. He had privileged access to the best geographical knowledge available in the Islamic world of the early 16th century. The Ottoman Empire in 1513 was the greatest political and military power in the Mediterranean, with networks of trade, espionage, and intelligence stretching from Spain to the Indian Ocean. If relevant cartographic information was circulating in the Islamic world, Piri Reis had access to it. In 1521, 8 years after completing the map we are discussing, Piri Reis published the Kitab al-Bahriyah, the Book of the Sea. It is a document that demonstrates exactly the kind of professional he was, a comprehensive nautical guide to the Mediterranean, with highly detailed descriptions of ports, currents, underwater rocks, seasonal wind conditions, and more than 200 regional maps of specific coastlines. The Kitab al-Bahriyah was not speculative or philosophical literature. It was an operational working manual used by real navigators on real missions, updated with data gathered from decades of direct experience at sea. Piri Reis knew how to distinguish empirical observation from speculation. He knew what a reliable map was and what was geographical fantasy. This is fundamental to understanding what comes next. The 1513 map was presented to Sultan Selim Mike as a gift, following the Ottoman conquest of Egypt, a fitting tribute for a conqueror who had just taken Cairo and absorbed the intellectual riches of the southern Islamic tradition into his empire. And along with the map, Piri Reis included something most cartographers of the era did not produce: a detailed explanation of how the map had been made. In this introductory note, he describes his sources with considerable specificity. 20 or more maps were used in the compilation. 8 were of Ptolemaic origin. derived from the geographical tradition of Claudius Ptolemy, the Alexandrian astronomer and geographer of the 2nd century Anno Domini, whose work had been preserved, translated, and reproduced across more than 1,000 years of Islamic and later European manuscript tradition. There were also Portuguese navigational charts, portolans captured during Ottoman naval battles, containing updated data on the African and American coastlines. And there was a group of documents that Piri Reis described as maps from the time of Alexander, ancient sources whose exact origin he does not specify, but which were clearly not contemporary cartography. This last group is what matters. The Ptolemaic maps have known provenance. They are derived from a Greek and Hellenistic geographical corpus preserved across centuries. The Portuguese portolans are recent 15th century coastal mapping. But the maps from the time of Alexander? The ancient documents of indeterminate origin that reached Piri Reis's hands through channels he does not explain? Those are the ones that contained the impossible data. Those are the ones that showed the coastline of a continent that Europe did not know. And Piri Reis told us they existed, but did not tell us where they originally came from. What became of them? They are among the millions of documents that history has lost. The looting of libraries, wars, changes of regime, the natural deterioration of materials that were never properly preserved. At any of these points across the centuries, the sources Piri Reis used may have vanished, or they may be sitting in some archive not yet fully examined, in Istanbul, in Cairo, in private collections of medieval manuscripts that have never passed before the eyes of a modern researcher. No one knows, and that is exactly the pattern by which inconvenient knowledge disappears. Not in a single dramatic act, in gradual silence, through neglect, through war, through institutional priorities that valued other things. What we know is that Piri Reis had them, and used them. The question passed to another man, 4 centuries later. Charles Hapgood's background was far removed from the geosciences or archaeology. He worked as a professor of history and social sciences at Keene State College in New Hampshire during the 1950s. By any conventional measure, he was exactly the kind of person the academic establishment would rarely take seriously when proposing a rewrite of the timeline of human civilization. But Hapgood possessed a rare quality. He was not afraid to ask questions that seemed impossible. And in 1953, after examining the Piri Reis map and several other historical cartographic documents with a careful methodology, he arrived at a conclusion he knew would be controversial. His hypothesis was that certain historical maps, Piri Reis's in particular but others as well, contained geographical information of far older origin than the period in which they were produced. That there existed, preserved in fragmentary and distorted form through chains of copying and retranscription, a cartographic knowledge of prehistoric origin that academia had neither recognized nor adequately investigated. To test and develop this hypothesis, Hapgood needed someone with the mathematical and physical competence to assess its technical implications, and he made a choice that, in retrospect, says a great deal about the seriousness with which he regarded his own work. He wrote to Albert Einstein. Einstein was 74 years old in 1953 and was, beyond any possible dispute, the most famous and respected scientist in the world. He was also known for a genuine interest in unconventional ideas, provided they had a rigorous empirical or mathematical basis. Hapgood sent a letter detailing his analysis of the Piri Reis map, the cartographic implications he had identified, and the technical questions he needed to resolve, asking for an evaluation. The response was not what Hapgood had probably expected. Einstein did not politely dismiss an enthusiastic amateur. He stated explicitly that he found Hapgood's hypothesis worthy of serious examination, and the correspondence continued. Over the following 2 years, the two minds exchanged letters in which Einstein offered specific technical assessments of Hapgood's proposals regarding spherical geometry, historical cartography, and the geophysical implications of what the maps suggested. In 1955, Hapgood was working on a book called Earth's Shifting Crust, a work that proposed a theory called Earth crustal displacement. The hypothesis that the solid crust of the planet, in response to the progressive accumulation of glacial weight at a pole, could slide as a unit over the fluid mantle below, repositioning the continents relative to Earth's rotational axis over geologically short periods of time. The theory held that Antarctica had, at some earlier point, been at a lower latitude, with a more temperate climate, with accessible coastlines, before the displacement that repositioned it over the South Pole. Einstein wrote the foreword. He died in April 1955 before the book's publication in 1958, but the foreword was complete before his death. In it, Einstein stated that Hapgood had presented a very important problem which deserves the serious consideration of every thinking man. A phrase that, coming from the greatest scientist of the 20th century, is not empty diplomatic language. It is explicit intellectual endorsement. The book was published with Einstein's foreword printed on the cover. The academic reception was, in any case, fundamentally indifferent. Alongside his work with Einstein, Hapgood had initiated contact with the United States Air Force. He shared his analysis of the Peary Race map with the Technical Reconnaissance Squadron, the unit responsible for cartographic analysis and aerial reconnaissance during the Cold War, which had access to the most advanced geophysical data of the era, including the complete results of the 1949 Antarctic seismic surveys. Lieutenant Colonel Ohlmeyer examined the material and signed the 1960 letter confirming the correspondence. Not because he was an enthusiast of alternative histories, because the data said what it said, and a military officer trained to read precise geographic data had no way to interpret the result otherwise. In 1966, Hapgood published the central work of his career, Maps of the Ancient Sea Kings, Evidence of Advanced Civilization in the Ice Age. The thesis was straightforward. The anomalies he had identified in the Peary Race map and in several other historical cartographic documents were consistent with only one explanation. Someone had mapped the world, including Antarctica, long before any civilization known to recorded history had the technical capability to do so. Academia received the book with the coldness it reserves for ideas it does not know how to refute within its own frameworks. The book sold widely outside academic walls. Within them, it was largely ignored. To understand why the Peary Race map sounds technically impossible against the traditional academic narrative, one must analyze how cartography was practiced in 1513, and what would actually have been required to achieve the level of precision the document displays. European Renaissance cartography relied on two primary methods. The first was direct coastal observation, navigators measuring compass bearings and estimating distances along coastlines they had physically traveled, producing Portolan charts, coastal navigation charts based on compass headings and distance estimates. They were useful for local and regional navigation. They were sometimes remarkably accurate for specific stretches of coast that had been traveled many times over, but they accumulated errors systematically as you attempted to connect distant regions to one another, because there was no way to compensate for the curvature of the Earth without advanced spherical mathematics. A Portolan of the Mediterranean was reliable. A Portolan attempting to cover the entire Atlantic was a collection of accumulated errors. The second method was what Ptolemy had proposed in the 2nd century, using a grid of latitude and longitude to position geographical features within a coordinated representation of the planet. The idea was correct in principle. The problem was execution in 1513. Determining latitude was possible with some precision. You measured the altitude of stars or the sun above the horizon, but determining exact longitude without a precision chronometer was impossible before the 18th century. A navigator in the Atlantic in 1513 could know reasonably well where he was in terms of north-south latitude, but his longitude estimate east to west could be off by dozens of degrees. Medieval and Renaissance maps show this clearly. Scandinavia frequently appears tilted at the wrong angle. The Mediterranean has an exaggerated length. The distance between Europe and Asia in the east-west direction is systematically distorted. These were normal errors, expected, inevitable given the tools available. Now consider what is technically required to produce the Peary Race map. The map uses a projection that distorts Earth's surface in a specific and mathematically consistent way, adjusting the scale of representations as distance from the central point increases, so as to compensate for Earth's curvature and preserve reasonable geographic proportions at a continental scale. This technique requires understanding that Earth is a sphere, calculating how different regions of the spherical surface relate to one another in scale, and applying spherical trigonometry to position each element geographically. The Mercator projection, the conformal mapping system that became the standard for modern cartography, was developed by Gerardus Mercator in 1569, 56 years after the Piri-Reis map. But the projection isn't the only technical problem. The Piri-Reis map is centered on Egypt and the Eastern Mediterranean. To use that point of origin and produce geographically accurate representations of continents thousands of kilometers away, representations that correspond to the actual positions of those continents with the accuracy that modern researchers have identified, you would need an understanding of global spherical geometry that European mathematics did not formally systematize until decades after 1513. Historical cartography experts used a technique called inverse analysis. They extracted the coordinates presented on the parchment and worked the math backwards to determine which spatial reference system would have generated that geographic arrangement. What they found, repeatedly, was that the map operates as if it had been constructed from coordinates calculated with knowledge of spherical geometry, equivalent to what was formalized in the West only in the late 16th and early 17th centuries, at least 50 years after Piri-Reis. For the parts of the map showing Europe, Africa, and the Americas, this is a difficult problem to explain, but one that could, in theory, have some conventional explanation not yet identified. A chain of transmission of Islamic or Greek mathematical knowledge that reached Piri-Reis through undocumented channels. And then we arrive at the real problem, the one that has no explanation within any historical framework that exists. To map the subglacial terrain of Antarctica, to represent the shape of the rocky coastline lying beneath kilometers of ice, with the accuracy confirmed by the USAF in 1960, there is no explanation within the cartographic tools available in any era before the 20th century. There is no method of observation, no technique of extrapolation, no mathematical theory that would allow a pre-modern cartographer to know what lies beneath an ice sheet. The only viable reasoning is that the original records were conceived when the region was accessible, when the coastline depicted on the map was free of ice, long before it was overtaken by glaciation. The mathematics points in one direction, conventional history points in another. Someone is wrong. There is an official explanation for the Piri-Reis map. It is important to hear it carefully and seriously, because it is not a weak explanation. It is carefully formulated, and in several respects, it is convincing. The central thesis of Hapgood's critics is this: the landmass in the lower corner of the Piri-Reis map is not Antarctica. It is a combination of two conventional cartographic elements of the time. First, the exaggerated extension of South America's coastline toward the south, a documented practice in Renaissance maps which frequently elongated Patagonia beyond its actual extent. Second, the speculative Terra Australis Incognita that 16th century geographic theory predicted must exist in the southern hemisphere, and which many cartographers included at the lower edges of their maps as a representation of theoretical expectation, not empirical observation. The combination of these two elements would produce a landmass in the lower corner of the map that, under the gaze of someone looking for correspondences with Antarctica, might appear similar, especially if one is not rigorous about the distinction between a general resemblance in outline and a specific correspondence of identifiable geographic features. It is a reasonable argument. It deserves to be taken seriously. The problem lies in what it does not explain. If the landmass on the map were conventional cartographic speculation, Terra Australis or distorted Patagonia, it should look like speculation. It should have the vague, generic, imprecise quality that representations of hypothetical land carry in every other map of the same period. The Terra Australis Incognita that appears in 16th century European maps is consistently just that: a phantom continent with undefined contours, with a position that varies from map to map, without specific internal features that can be identified and compared to geographic reality. The critics are right that such a tradition existed. What they cannot explain is why the result on the Piri-Reis map has specific features that correspond to subglacial data. What appears in the lower corner of the Piri-Reis map does not look like speculation. It has bays with identifiable shapes. It has promontories with verifiable orientations. It has the kind of articulated detail you would expect from someone who had been there, or who had copied from someone who had been there. And that correspondence is not with the ice-covered Antarctica as it appears today. It is with the subglacial terrain, which no one could see, which was invisible to every pre-modern instrument, which remained hidden until 20th century seismic surveys revealed it. The official explanation can accommodate a superficial resemblance between the map and the general shape of the Antarctic region. It cannot accommodate the specific correspondence with subglacial topography, confirmed by seismic data from 1949. And that is precisely the distinction Ohlmeyer's letter makes. He did not say, "The map looks somewhat like Antarctica." He said that the geographical details agree very remarkably with the results of the seismic profile. Remarkably, with the subglacial data, with information that was not available to anyone before 1949. It is time to reconsider what you accept as the limit of what ancient civilizations knew. Because the answer academia gives for this specific map, convenient cartographic speculation, does not survive confrontation with the data that the American official confirmed in writing 65 years ago. If the Peary race map were the only case, it might be possible to construct a satisfying argument that we are reading too much into something that is, at its core, a remarkable but explainable cartographic coincidence, an unlikely statistical outcome, but not an impossible one. But it is not the only case. 18 years after Peary Race completed his map in 1531, a French cartographer named Orontius Phineas published a large world map. In the lower corner, he also depicted a southern continent. And this is where it gets truly strange, because what Orontius Phineas drew is fundamentally different from any representation of the speculative Terra Australis produced by other cartographers of the time. The continent on the Orontius Phineas map is not a vague, hypothetical landmass. It has an articulated coastline with specific indentations that can be compared against modern data. It has rivers drawn flowing from the interior toward the sea, implying an ice-free interior. A continent with active hydrology, not the frozen desert Antarctica is today. It has what appear to be mountain ranges indicated along the coast and through the mountainous interior. The continent is correctly positioned relative to the geographic South Pole, not in a variable position like the speculative Terra Australis of other cartographers, but in the right place, at approximately the right size, with the correct orientation. The Orontius Phineas map was produced 289 years before the official discovery of Antarctica in 1820. Hapgood compared the Orontius Phineas map with modern mapping data and identified specific geographic correspondences along the coastline. The entrance of a bay corresponding to the Ross Gulf, coastal features in identifiable sectors of East and West Antarctica. Not a perfect correspondence. There are errors and distortions, which would be expected in a copy of an original document that passed through millennia of transmission, but specific correspondence enough to create a serious problem for the speculative coincidence narrative. One map with impossible information could be coincidence. Two maps with impossible information make coincidence far less plausible. In 1737, 183 years after Orontius Phineas, and 83 years before the official discovery of Antarctica, a French cartographer named Philippe Buache published a map of the South Pole region. Unlike a mere enthusiast or speculator, Philippe Buache held the prestigious post of first cartographer to the King of France. He was the French state's foremost expert, a member of the Royal Academy of Sciences in Paris, the owner of a career defined by scientific rigor. As his maps served as official instruments for military and naval planning, Buache was the last professional who should have been producing charts with impossible information. On Buache's 1737 map, Antarctica is divided into two separate landmasses, separated by a water channel cutting across the continent. In 1820, when explorers finally reached Antarctica, what they saw was an apparently solid ice-covered continent, a single continuous landmass. The division Buache depicted seemed absurd. Why would one of Europe's finest cartographers be showing a continent split in two when the continent clearly was not? Based on the sources Philippe Buache used, whose content he likely did not fully understand, because he had no way of understanding what he was reproducing. What modern ice-penetrating radar research revealed decades after Boache had been dead for 2 centuries, is that beneath the Antarctic ice sheet, there are effectively 2 distinct continental fragments, separated by a subglacial basin that the ice fills completely. Antarctica is, geologically, 2 pieces of continent that the ice transformed into an apparently single block. This was not visible on the ice surface in 1820 or in 1737. It was invisible from the surface until 20th century technology penetrated the ice and revealed what lay beneath. Felipe Boache's 1737 map showed the division correctly. Now we have 3 maps, 3 cartographers, 3 different countries, 3 different centuries, all carrying information about Antarctica that no known civilization in recorded history had any means of obtaining, and each with a different specific detail confirmed by a distinct modern technology. The subglacial coastal topography on the Piri Reis map, the hydrology and coastal contours on the Orontes Phineus map, the continental division on the Boache map. 1 map could be coincidence. 2 maps make coincidence less plausible. 3 independent maps, each with specific and distinct correspondences confirmed by distinct modern data. That is not coincidence. That is a pattern, and patterns have causes. The pattern created by these 3 maps points to a single conclusion, and it is an inference that official historiography is not prepared to accept. There were sources, ancient sources, of unknown origin, that contained real geographic information about Antarctica. Information gathered when Antarctica was accessible, when the coastlines the maps depict were above water, and could be observed and recorded by people who were physically there. These sources reached Piri Reis, Orontes Phineus, and, more indirectly, the collection to which Boache had access, most likely through the cartographic tradition that passed through the Library of Alexandria and through the great centers of knowledge preservation in medieval Islam. Each cartographer copied what they found, with greater or lesser fidelity, with greater or lesser understanding of what they were reproducing. The question that emerges is, who produced the original sources? Who was in Antarctica when Antarctica was accessible? The geological data establishes the possible time frame. Antarctica had relatively accessible coastlines during the interval geologists call the Younger Dryas and its transition, roughly between 12,000 and 6,000 years ago. This period corresponds to the end of the last ice age, an era of massive climatic disruptions, of rapid sea level rise, of entire ecosystems vanishing over centuries rather than millennia. It is the same period in which, across cultures distributed throughout every inhabited continent, Mesopotamia, India, Central America, Greece, Egypt, there are narratives of flood, of catastrophic destruction, and of new beginnings. Narratives that most cultures recorded as memory of a real event, not as allegory. 12 to 6,000 years before the present is a period in which, according to conventional history, humans were at most developing the first sedentary cultures, the first experimental agricultural practices, the first permanent villages. The great cities of the Fertile Crescent would not begin to emerge until approximately 5,000 before Christ. Writing would not be invented for another 2 or 3 millennia. The long-distance ocean navigation that historians recognize as documented begins centuries after this period. And yet, someone was in Antarctica, someone with sufficient open ocean navigation capability to reach a continent at the far south of the planet, a journey that requires crossing the most hostile seas in the world, what we today call the Drake Passage, with weather conditions that have killed modern navigators who were abundantly equipped. Someone with sufficient knowledge of spherical geometry to produce coordinated, precise cartography that would propagate, in fragmented and distorted form, across millennia until reaching the hands of Piri Reis, Orontes Phineus, and Felipe Boache. In 1995, Graham Hancock published Fingerprints of the Gods, a work that became a publishing phenomenon and brought these questions to a far broader audience. Without holding academic credentials in archaeology, Hancock applied his decades of experience as an investigative reporter to do what his profession does best: a rigorous sweep of empirical evidence that academia had chosen to ignore. Hancock's central hypothesis was not supernatural. It did not involve aliens. It did not invoke magical technology or inexplicable powers. It was simpler and more unsettling than that. There was a civilization, It was advanced enough to navigate oceans systematically, to produce precise spherical cartography, and possibly to accomplish other feats of engineering and social organization that we still do not fully understand. It existed in a period prior to what history books recognize as the beginning of civilization, and at some point, most likely during the catastrophic disruptions of the end of the last ice age, when sea levels rose in some locations by more than 100 meters within a few generations, it was destroyed or profoundly disrupted, leaving only fragmented traces in documents that have reached us indirectly and in largely distorted form. The Library of Alexandria remains the most plausible candidate as an intermediate repository. The library, founded in the 3rd century before Christ by Ptolemy the Soter and aggressively expanded by his successors, had become the largest and most ambitious knowledge accumulation project of the ancient world, with agents dispatched to buy, copy, or seize manuscripts from across the entire Mediterranean basin, the Near East, India, Persia, anywhere travelers and merchants could bring texts from. If maps of prehistoric origin survived the civilization that produced them, Alexandria would be the most likely place to find them, and the Ptolemaic maps that Piri Reis described as sources derived directly from the Alexandrian cartographic tradition. The library was not destroyed in a single dramatic fire, as popular myth suggests. It was destroyed gradually over centuries, acts of vandalism, restricted access, wars, progressive neglect. What survived was scattered, poorly copied, translated with errors accumulated across generations of scribes who did not understand what they were reproducing. A map of an ancient civilization that reached Alexandria through unknown means, copied by a scribe who had no geographical context to understand what he was reproducing. Recopied 3 or 4 more times over millennia, arriving at Piri Reis in 1513 as something he recognized as an ancient map, but could not fully interpret. That is the mechanism the evidence suggests. What does have an answer, partial, confirmed by American military data and geophysical research, is that the maps exist, and that they show what they should not be able to show. The most disturbing question the Piri Reis map raises is not a technical one. It is about how human knowledge works, and what happens when a piece of evidence does not fit into the box the system has prepared for it. The map was discovered in 1929. The first serious examinations came in the 1940s. Hapgood published his complete analysis in 1966. The U.S. Air Force confirmed the topographic alignment of the relief in 1960. Einstein endorsed Hapgood's work in 1958. 65 years have passed since Ohlmeyer's letter. The map remains in the same category it was in when Deisman catalogued it in 1929, an Ottoman historical curiosity. There is no active conspiracy to suppress the Piri Reis map. There are no government agents hiding evidence in secret vaults. What exists is something harder to fight than an active conspiracy: institutional inertia, the weight of established paradigms, the prohibitive cost, for any individual academic career, of revisiting fundamental premises that an entire discipline has built over generations. History as an academic discipline is built upon a framework that states, advanced civilizations began to emerge between 5,000 and 6,000 years ago. Writing, sophisticated mathematics, long-distance oceanic navigation, coordinated cartography, all of it came after that period. This framework is not arbitrary. It is based on decades of careful archaeology, site analysis, carbon dating, evidence that has accumulated over a very long time, and that is, within its own parameters, robust. Accepting the hypothesis the maps suggest would not mean adjusting one detail of that framework. It would mean rebuilding it from scratch. It would mean that everything we think we know about when humans developed oceanic navigation and spherical geometry needs to be revised. That the timeline running from stone to bronze to iron, from Sumer to Rome to the Renaissance, may be incomplete in a way that is not a minor detail. It is a gap of tens of thousands of years. The academic cost of endorsing this hypothesis is enormous for any individual researcher. An archaeologist who publishes a paper favorable to Hapgood is not simply adding a perspective to a debate. They are potentially signaling that they consider invalid the framework underpinning their entire field, all of their peers, the entire structure of research funding, publication, and professional credibility that defines a career. The academic journals that rejected Hapgood's work in the 1960s and 1970s were not necessarily acting in bad faith. They were applying the standard criteria of a system that, by its very structure, has no mechanism to accommodate evidence that invalidates its founding premises. After Einstein died in 1955, the endorsement he had given to Hapgood's work lost much of its practical weight. No other scientist of comparable stature stepped in as a public validator. Maps of the Ancient Sea Kings was widely read outside academia, debated in alternative history circles, popularized by Hancock and other authors, and essentially ignored by the university departments that would have had the resources and methodology to examine its claims with the necessary rigor. Ohlmeyer's letter was never formally refuted. No institution published a detailed analysis showing where the lieutenant colonel was wrong, or how the correspondence he confirmed could be explained within the conventional framework. The letter exists. The geophysical data it cites exists. What does not exist is the integration of that data into the historical narrative taught at universities. This is what institutional inertia looks like in practice, not active suppression, gradual forgetting, passive marginalization. The system does not destroy the evidence. It lets it exist on a shelf, in a category labeled curiosity, while academic life continues around it as though it were not there. And time passes, and the evidence ages on the same shelf where it was placed in 1929. We have arrived at the end of what the evidence concretely asserts. There are two possibilities. The first, the three maps are extraordinary and independent coincidences. Piri Reis, Orontius Phineas, and Boache produced representations of an unknown continent that accidentally correspond to real topographical features confirmed by 20th century technology. The subglacial fit attested by the USAF would be nothing more than a partial overlay that only appears so precise to eyes applying excessively lenient criteria. The pattern we see across the three maps is our brain-finding order where there is nothing but statistical noise. Hapgood's critics are right. The second, the sources that Piri Reis described in his introductory note were real. They contained geographical information of far older origin than 1513, collected when Antarctica was accessible, preserved through transmission channels that did not survive intact to us, reaching Piri Reis and other cartographers as distorted fragments of an original documentary corpus. If this is true, then someone, living in a period largely ignored by textbooks, possessed the technical capability to navigate open oceans and map continents with spherical precision. We do not know which of the two is true, not with enough certainty to rewrite textbooks. But the second hypothesis is the only one that does not need to dismiss Ohlmeyer's letter in order to work. The original map is in Topkapi Palace in Istanbul. Anyone can visit it. The question the map raises is simple to formulate, but challenging to answer. Someone, in an era that academic consensus refuses to acknowledge, was there. That person mapped the coastlines and documented the terrain before ice erased it from view for millennia. And that record reached us, distorted, fragmented, reduced to the lower corner of a gazelle skin parchment kept in an Ottoman palace. Not in the form of an answer, in the form of a question that refuses to be silenced. We have not yet answered what that map is asking. If these questions interest you, if you want to keep following the cases that official history does not know how to explain, the channel continues this investigation every week. The next piece of evidence is waiting.